Today, we actually talk on alternative currents, instantaneous current, voltage, and corresponding power. Before diving to the deep, we first take some idea about what DC current and alternative current means and their differences. We might know from the previous lesson of this course, CSC 205, that what DC current actually is. DC current actually represents D for direct and C for current. So if we plot DC current like this way, like according to x-axis, we represent time, according to y-axis, we represent I, that at time t1, this current value is, let's say, 5, and at t2, this current value is 5, at t3, current value is 5. So whatever time it is, whatever time you are varying, the current value is not changing. So that type of current is we call the DC current. So uh, the current which does not change its direction or its magnitude is actually the DC current. Whereas what alternative current means, if we represent an alternative current like this way, like a sinusoidal curve, A sine omega t. So if we represent same familiar way, the same pattern like x-axis time, y-axis I. So if we notice this curve that from this point to this point, this interval of time, the value of I is moving to the positive y direction. So here we get the current value positive, and during this interval, from this point to this point, we are getting negative y value. So I value is negative. So if we represent the positive value like this way, from A point to B point this way, then the negative value will be represent the reverse way, like from B point to A point. Look, this way current direction is this way current direction is this. This is how it's alternating its direction. That's why we called it alternative current. If we notice this graph deeply, like if we sample this point, we are getting one value. If we sample this point, we are getting another value. If we take this point, we are getting another value. So each time is varies its direction as well as its magnitude. That's why it actually represents the alternative current. So why we actually need to deal with this AC current and alternative current? We might know that in our household and industry, everywhere we are getting AC supplied. So as we are getting AC supplied voltage, we also get the AC current voltage. That's why we need to do this alternative voltage and current and their corresponding power. Let's say here we are connecting a bulb to a AC voltage. Let's say that bulb has a resistance 5 ohm. So if we supplied a voltage like 5 sine omega t, then we will get current according to Ohm's law. I is equals to V by R. Then the current value will be sine omega t. So we see that current is same sinusoidal curve, just its magnitude is different as this load is resistive. So how do we calculate its power? So from our previous lessons, you might familiar with this equation that P may be represented like V square divided by R or I square divided by R or VI, any three of them. So to need to calculate them, we need to take sample power output. So if we take this point at T1, we are getting I value 0.02. If we take this point at T2, we are getting I value 0.03. If we are taking this point, we are getting I value 1. So at this point, power P1 will be 0.02 square divided by R, P2 will be 0.3 square divided by R, P3 will be 0.01 square divided by R. So you may notice here that each time power is changing, zero point 0.2 square, 0.3 square, 0.01 square. So it's fluctuating. What it will happen if fluctuate this way? Look, this time power is low, so this light intensity will be low. And this time power intensity is pretty high, so intensity will be also high. So this time intensity is much higher, so power is much higher, intensity will be much higher. So as the power fluctuates, light's intensity will also be fluctuates. So that might be a problem. That's why we are very concerned to calculate the average power. How do we actually calculate average power? So before calculating average power, we actually recap what actually average is. What actually average is? Average is the sum of the value divided by number of sample. If there is a two value A and B, and their value is A and value is B, and there is 2 points A and B. So what will be the average? Average will be A plus B divided by 2. So let's say then how we will calculate the average power here. So here let's say we take n sample. Here we take n samples. Okay. So what will be average? P1 plus P2 plus P3, P4, Pn divided by number of samples n. So what actually P is? P is equals to I square divided I square R, I1 square R, I3 square, In square divided by n. Then if we common this R, then what it will be? I square, I2 square plus In square divided by n. Okay. Now we represent this equation to our known familiar equation. We need to represent this equation to our familiar equation I square R. What we will do? We may take this part to a new variable I prime square. Then what it will be? Let's say I prime square equals to this portion. I1 square, I2 square plus I3 square divided by n. So what will be I prime? I prime will be root of this. So we modify, if we modify this equation, if we modify this equation, like we are taking 1 by n at the front, then the squared value there, and there is the root. So this is the squared value, this is 1 by n, this is 1 by n, and this is the root. So what actually 1 by n? 1 by n comes from the average, here is the root, here is the squared value. That's why we can name it root mean square. So I prime, we can say it I RMS. So here we can calculate the P average as I RMS square into R, resistance. Okay, so this is how we can calculate the P average. So if we know the IRMS value, then we can easily calculate the P average. Let's say here we are what actually do. We actually take discrete samples over the period of a sinusoidal curve. But we need to take every instantaneous point, so every continuous part of this curve. So we might know that if we want to continuously add everything, this summation will be replaced by integration sign. It's this idea we had from integration. You might know from your math courses. And here, as before we take n samples, here we are integrating over this period. So averaging over 1 by t. So that's why this summation will be replaced by integration. 1 by n replaced will be 1 by t, and integrating over dt. Okay, then how we actually do RMS value? Root of 1 by t is 0 to t integrate from I square dt. So then how we will calculate this? So let's say our I curve is sine omega t. This curve is this, and what will be I square? I square will be like this. As a square term, we will get positive value, so this negative portion will be like this and will be this curve. We need to integrate this curve. So how do we integrate this curve? It's a pretty easy integration. We might do it easily as we already done math courses. So a square divided by 2 sine omega t. Then after integrating, we will get this value, a square divided by 2 into t. This is the integration of I square. To get the RMS value, we need to divide it I square divided by t. So what it will be? So if you divide it by t, then it will be a square divided by 2. Then to get the RMS, we need to root it. So if you root it, then it will value will be a divided by 2. So if we know the maximum amplitude of a sinusoidal curve, then we can easily calculate the RMS value like this equation, a divided by root 2. So if we know a sinusoidal curve like this, and here maximum amplitude is a, then RMS value will be a divided by root 2. If we take if we, let's say I is a sine wave, okay, then a sine omega t, then what will be the RMS will be? I RMS will be a divided by root 2. Then let's say we need to calculate V RMS. So V is equals to V sine omega t. Then similar way we can take the V RMS is equals to V divided by root 2. If we take the RMS value, then we can easily calculate the power with this equation, like I square I RMS square R and V RMS square divided by R, or I RMS into V RMS. Any of three equation we can easily calculate the average power. So today this is it, and if we do some practice math and other stuff, then our idea will be again clear. So thank you.